Hello everyone, thank you so much for tuning into my talk, and thanks to Ore Deposit Hub for asking me to present on my work. I'm with the Northwest Territories Geological Survey. Our office is based in Yellowknife. I am part of the Mineral and Bedrock Mapping Group, but our office has a really diverse set of research scientists, and through collaborations with academic and research partners, we're able to conduct a lot of work across the Northwest Territories, which is a really big undertaking. So thank you to start off this talk to all the people that I've worked with in the field. Thank you for your advice, your competent assistance, all of your ideas, and really this work wouldn't be possible without all of the people that I've listed here. All right, so jumping into the geology of the slave craton. On this simplified map, the rocks in purple represent the basement complexes and the oldest rocks in the slave craton. This is the Acasta gneiss at 4.03, down to other intrusive rocks as young as 2.8 billion years old. The rocks of the central slave cover group are not represented in a color on this map, but they locally sit along the edge of the basement complex. In green are the greenstone belts of the slave craton. In the Yellowknife greenstone belt, these are the tholeiitic basalts of the 2.73 to 2.70 chem group, and the bimodal volcanism of the calc-alkaline 2.68 to 2.66 billion-year-old Banting group. And then their equivalents and interpreted equivalents in greenstone belts across the craton. In gray, we have turbidites, and a lot of this map is light pink, which is different granite suites, which are as young as 2.58 billion years old. Often when we discuss the slave craton, we do it from a Yellowknife greenstone belt centric point of view, which is a good starting place for testing hypotheses and for making comparisons. But for people who've worked in the slave craton or studied it, there really are still a lot of outstanding questions, even in our own backyard here in Yellowknife. Particular interest to this talk are the tectonic setting and placement of volcanic rocks and the geodynamic processes that control this, as well as metal endowment. So getting into models of amalgamation of the slave craton formations of greenstone belts is a talk completely unto itself, but I will show these two different models. In the past 5 years, I've found that there is a certain elegance to both of these models at the regional scale, as well as in specific parts of greenstone belts. With this study, we're aiming to understand VMS deposits within this context. And by taking a closer look and mapping in detail, we're really looking to test these models in the course of our work. So the project rationale in the most simple terms is to look at details of the lithofacies and geochemical signature in volcanic belts. A lot of the mapping has been taking place at about 1 to 15,000 scale, with complementary transect mapping at 1 to 5,000 and 1 to 2,000 scale. The work is being conducted both in areas of known VMS mineralization and in areas that appear to be under-endowed. The project is also picking up where exploration and research left off in the late 80s and early 90s, at the time where the diamond rush began in the Northwest Territories. This work is also continuing on a project that Valerie Jackson and Luke Oots had imagined and begun working on while they were still at the Northwest Territories Geological Survey. So thanks to them for creating a great project. So today, I'm going to highlight 3 different areas of study that are helping us move towards understanding a volcanogenic massive sulfide mineralization in the slave craton. I'm going to start by discussing details of mapping of felsic volcanic rocks in the area of the Sunrise VMS deposit in the Bolio Greenstone Belt. So that's the southern Sunset Lake area. Then I'll move north into a study of mafic volcanic rocks and VMS-style bedrock geochemical anomalies in the Winter Lake Belt. And finally, I'll finish with a new project that I've just begun in the Point Lake area that's utilizing a new aeromagnetic survey. Okay, so jumping into the geology of the Bulio Greenstone Belt. The Sunrise VMS deposit is shown in a red star on the east side of the Sleepy Dragon basement complex. It's within the Sunset Lake subarea, and the work here is focused on understanding the age, the stratigraphy, and the petrogenesis of volcanic rocks in this area. Despite advanced exploration in the late 80s and early 90s, there is relatively little published about these details of the VMS deposit. There's a lot more information for us to glean about the tectonic setting and the metallogeny of this area, and things that we can extrapolate both within this greenstone belt and hopefully carry out into the larger craton. Through bedrock mapping and relogging of drill core at the Sunrise VMS deposit, we see that in the immediate footwall of the deposit, we have QFP lobe haleoclastite flows, competent flows ranging from QFP to apheric rhyolates, and then younger chloratized felsic lapillistone that are hosting the mineralization. On the bottom part of this slide, I've included the historic non-43101 code compliant indicated resource and inferred resource for this deposit, as well as some of the grades. As we move up into the hanging wall of the deposit, we see a carbonate altered massive and pillow basalt flows with mafic volcanoclastic rocks and zones of breccia. Our work revealed synvolcanic faulting adjacent to the rhyolite domes. This is consistent with a subsidence structure or a graben. In addition, the new chemostratigraphy and the alteration study that we've done indicates that this specific mineralizing event horizon is not continuous to the south, as was suggested by Lambert in 1988 after his 1 to 50,000 scale mapping. Our work shows that the greenstone belt builds with a series of pillow basaltic andesite flows, followed by rhyolitic volcanism and pyroclastic eruptions, as well as synvolcanic faulting. The synvolcanic faults would have acted as magma conduits and then hydrothermal pathways for the metals. The Sunrise VMS deposit is shown in gray and red on this image and is shown venting on or just below the seafloor, right along the margin of a rhyolite dome margin. On the ground, in this area, in the immediate area, we see isolated outcrops of argillite, of fine-grained water-lane volcanoclastic material, but these, as well as the alteration, do not continue along strike. So when we go about 5 kilometers south to the Sunset Rhyolite Dome, which is shown here on a 1 to 2,000 scale map, we again see that we have stratigraphy that is oldest in the west and youngest towards the east. This stratigraphy builds from thalatic basaltic andesite flows in green into abundant volcanoclastic deposits and competent rhyolite flows in yellow. Shelby has done an excellent job of documenting the different lithofacies in this area, and we see that the volcanic strata is a homoclinal sequence that youngs to the east and was deposited in a subaqueous environment. A lot of it is vent proximal, and again we see this stratigraphy younging and terminating with a conformable contact with the turbidites of the Burwash Formation. Some of the geochem plots here show trends from thalatic to alkaline magmatism. We have mafic volcanic rocks plotting in arc basalt fields, and on the right side of the screen there's multiple clusters of geochemically distinct volcanic rocks. The alteration patterns that we saw in the Sunset Lake area were very similar to that observed at the Sunrise VMS rhyolite and in that host stratigraphy. So by looking at these two different rhyolite domes in detail, we see that we have two different ages of prospectivity for VMS deposits in this area. Okay, so now we'll move about 200 kilometers north into the Winter Lake Greenstone Belt. This area has preserved a relatively complete geological stratigraphy of the Slave Craton. In green are Cam and Banting Group equivalent volcanic rocks, and there's also an older volcanic package, the 3.3 to 3.1 New Bigging Formation, which is represented in yellow. This area gives us an opportunity to map in various structural domains, so we're not just looking at volcanic rocks transposed into a north-south orientation, which is allowing us to examine the relationships between the different types of supercrustal rocks. When we zoom into the Big Bear and New Bigging Lake area, we'll go into this next, and I'll show 4 of the bedrock geochemical anomalies that are known in this area. I guess the main takeaway from this slide is that we have a set of zinc, lead, and copper anomalies that have been described in really different rock types. So with this diverse set of showings, we really have the aim of placing them more robustly into the volcanic stratigraphy. We have a copper showing that's described in a tonalite, and it really seemed like it would be possible to gain more detail about the mineral deposit style in this belt. And so now I'll zoom into detailed mapping that was done in the area of the 152 showing. On this map, there are massive and pillow basalts that are represented in the light green colors. These have abundant younging indicators that show the volcanic stratigraphy younging to the southeast. In dark green, there are outcrops of gabbro that were interpreted to be synvolcanic intrusions, and this is in a high strain contact with turbidites to the northwest. In browns, there are massive sulfide lenses that are parallel to the volcanic stratigraphy. They're also sitting along faults that we interpreted to be synvolcanic in nature due to the changes in stratigraphy across their boundaries, and those were likely reactivated faults younger in the geological history. Some assay results from the 152 showing and a flip side showing that we described this past summer. And despite the metamorphic grade, this seemed like an area where we really were able to distinguish different types of volcanic rocks and gain a lot more perspective on where these massive sulfide occurrences were sitting. In another map that was done about 6 kilometers to the south, the shore of New Bigging Lake, we were able to see in greens a mix of apheric massive mafic intrusions, medium-grained mafic intrusions, pillow basalts, and then in yellows, some minor felsic tuff units and competent rhyolite flows. A really neat part of this work is that in the field, we were able to distinguish different types of coarse-grained mafic material. So the red lines on this extended rare earth element spidergram show in red what we thought were gabbro intrusions that were not related to the volcanic stratigraphy, and in black, the rocks that we thought were volcanic in origin or synvolcanic mafic intrusions. We can see a difference in the negative niobium anomaly, and I think this work, the mapping with the geochemistry combined, really goes a long way in explaining some of the variations that we see in metal endowment in the Winter Lake Greenstone Belt. There simply aren't VMS showings in mafic plutonic rocks, and I think this geochemistry is going to give us an exploration strategy that at a minimum we can use within the Winter Lake Greenstone Belt, but hopefully can apply to exploration in other areas. All right, so now we're going to move into the final example of the VMS focused mapping that we've been conducting. We're going to move into our most northern map area at the Point Lake Greenstone Belt. This Greenstone Belt is in both the NWT and Nunavut. On the Nunavut side, we have the Izok, Hood, and Gondor VMS deposits, as well as the past-producing Lupin gold mine. On the NWT side, there's been advanced exploration for gold and banded iron formation. There's several kimberlite targets, and in the course of this work, we've seen new VMS-style showings along the shore of Point Lake. This is a bit of an anomaly in the fact that there has actually been a lot of previous work done in the area. There's been drift prospecting projects, studies of the structural geology, there's been geochronological studies, and regional mapping. So really the focus of our work is to build on what's already been previously done to actually come in here and be able to ask and test a bunch of questions that we have. So looking at the NWT portions of these greenstone belts, is there a different style of VMS mineralization from what we see farther to the north? And if so, what are these differences? We can look at questions like, do we have a continuous tectonic environment and placement of the greenstone belts along strike? What are the vectors to mineralization within this belt? There's a lot of stratigraphy that's quite complete, but there are different structural panels, different crustal depths, potentially different ages of volcanic rocks here. So the work that I've been doing was in Cascara Bay in 2019, and in 2020 I went to the Arrowhead outlier and was able to do some limited capacity mapping this past summer. Another part of the rationale for going into this area is the high resolution fixed wing aeromagnetic survey that's been done. This was funded by the Canadian Northern Economic Development Agency and has been released as an NTGS open report 2019-003. There's also going to be interpretations of this data as well as 3D inversions that will be released quite soon. I'm going to focus on the area that's outlined in this black circle. This is the Arrowhead outlier portion of the Greenstone Belt. In 2020, I began work in this area, and I just wanted to show some of the data that we have. So this is a magnetic susceptibility voxel with isosurfaces of different susceptibility levels on the bottom portion. There's a 2D plane of the residual magnetic data, and then on top we have the geology draped over a topographic surface. So this is really giving us an opportunity to understand the slave craton in 3 dimensions in a way that we weren't able to in the late 80s and early 90s. And a lot of this is based off of exploration for kimberlite. So a few conclusions. This work is really looking at understanding the early history of the slave craton, the environments for emplacement of volcanic rocks and the related sedimentary rocks. Through different targeted projects, we are hoping to improve the knowledge of ore forming processes, and some examples of what we've done so far is looking at multiple ages of rhyolite domes within volcanic belts. the ability to divide greenstone belt geology between intrusive and volcanic material, putting VMS style showings into a litho and chemostratigraphic context within these volcanic sequences, and also looking at slave craton architecture in a way that hasn't been possible in the past. A lot of this work is spanning multiple greenstone belts, land dispositions, and land claims areas. And that's kind of a cool part about government geoscience. We're really able to focus on creating this pre-competitive data, generating ideas of regional geoscience, creating new ideas about exploration targets over multi-year projects. And the partnerships that we have really bring a lot of value and depth to this work. And of course, training new generations of bedrock mappers and exploration geologists. So hopefully you will reach out to me at the Northwest Territories Geological Survey, and I encourage everybody to check out our 2020 NWT Nunavut Geoscience Symposium. This is a virtual conference that will have posters and pre-recorded oral presentations. It's all available free after November 23rd, so please check out our website for more information. Thank you very much.
Okay, thank you very much, Bernadette, for this really nice overview about these remote areas. So now we have Bernadette with us to answer your questions.
Yeah, thanks everyone for the opportunity to present. I was very happy to send a pre-recorded talk, but happy to be here today live, and yeah, happy to answer any questions that you have.
Okay, we have the first questions arriving. Okay, the first one is from M. Sanborn. Do you want to unmute yourself and ask the question?
Hi, Bernadette, can you hear me?
Yes, I can.
I just wondered, I don't know if I missed any age data. How did the ages between the three volcanic sequences compare?
Well, we're in the process of dating the rhyolites from the Sunset Lake area, and the preliminary data from there gives Banting group equivalent ages, so around 2.68 for those rhyolites. We don't have any dates that we've generated from the Winter Lake belt yet, but the competent felsic rhyolite flows of the Newbigging Formation, there's a couple ages there, and those are 3.3 and 3.1. So those seem to be volcanic rocks that are older than Cam and Banting equivalent volcanics, so older than the majority of the mafic material in the Winter Lake belt.
And maybe, or is 3.3, 3.1 comparable to Point Lake? Sorry, I don't remember those ages, or is Point Lake volcanics quite young, like Newarkian?
Yeah, I love that somebody thinks that those are young. I'm in the same boat. I think it was a Northrop et al. Study that looked at some of the synvolcanic mafic material that intrudes into the Augustus granite at Point Lake. And yeah, those came out around 2.7 billion years. But when you move farther into Nunavut, there are some around 3 billion year old volcanic rocks in that area. So yeah, that's definitely some stuff that will come out of this work, is some precise ages, and especially in the Sunset Lake area where we have competent rhyolite flows that are quite well preserved, we should be able to get some really clear ages, and definitely different for me to have geochrone ages with a plus or minus 1 million year error. It's a change from the rate craton for sure.
Yeah, great. Good. Very good talk. Thank you.
Thanks so much.
Okay, thank you so much. We have another question from Melissa. She's asking is there a lot of industry exploration for VMS in the slave these days?
Yeah, that's a great question. There isn't too much work that's happening right now. Actually, I've been just in touch recently with Dave Webb. He's with 60 North Gold Mining Company. They're there's a lot of work that's being done in the greenstone belts with the focus of gold exploration. But a lot of the style of the mineral deposits are really in places with potential for gold, but VMS deposits as well. And even just some of the drilling that's been happening right in the Yellowknife Greenstone Belt by Gold Terra, we're also seeing VMS style lenses within that drilling. So I hope that there'll be more exploration for VMS deposits, especially on the NWT side in the future.
Okay, thank you so much.
I guess just one more thing to add there.
Okay.
Even from the work that I'm doing, as you're walking over these volcanic belts, regardless of what type of mineral deposit you're looking for, looking for those alteration patterns. And I know some of the geologists that are exploring for gold are starting to think about VMS alterations, so primary alterations that would have affected the volcanic rocks. And that's kind of nice. I suppose people might be looking for gold, but it would be also great to find a VMS deposit at the same time.
Okay, I have one just quick question. I don't know if I missed it. You talk about the mineralization in volcanics. There are any evidence for mineralization in sedimentary sequences?
Yeah, we have seen some of that. So not VMS style mineralization, but in conglomerates that are equivalent to Jackson Formation Temiskaming type conglomerates, which have an age of about 2.6 billion years. We do get remobilized sulfides sitting along fracture networks within that. We've also seen sulfide mineralization in quartzites. So it's probably all remobilized using younger faults and fracture networks.
Okay, thank you. Yeah, let's wait a bit if more questions arrive. Just one more, because I'm really interested about metasediments. Which kind of assemblage do you find in these quartzites?
Well, in the quartzite, it was mostly pyrite that was coming in along fractures. Yeah.
Okay. Thank you very much.
Yeah, and for everybody that's listening that would normally be joining us in Yellowknife for the Geoscience Forum, please look back to our website and join us for our virtual symposium this year. It's happening in about a month.
That is all the time that we have for today. Thank you everyone who asked a question, and we are sorry if we weren't able to get to your question. Mike and Bernadette are both available for any of your questions. And yeah, join us next week. Thank you everyone, and thank you to our speakers.
Yeah, thank you very much, and thanks everyone for coming out.
Thank you. See you next week. Thank you very much.